This is example 15.3 from Discovering Design with Chemistry. A chemist does an experiment with the following reaction. Bam. She runs 3 separate trials of the reaction, varying the concentration and measuring the instantaneous rate. So you can see the NO2 has 0.263 for the first 2 trials and then 0.526 for the last one, and the CO has 0.826 molarity for the first one and 0.143 for the last 2. And then each of those concentration combos gives us a different, or well, not really, gives us different instantaneous rates. The first 2 actually end up being the same. So that might hint at something, but we will talk about that when we get to the end. All right, so this is exactly the same as the last one. It just has one more little sticky thing in it, and it's just extra practice before you do these on your own. So we're going to start by just writing the rate equation, and I didn't put my little pink box up here this time, but I'm hoping you know it by now. K A to the X, and then B to the Y. And in this case, A would be NO2, and then B would be CO. All right, so that's what we're going to work with. So let's start with number 1. So trial number 1, our rate is 1.44 times 10 to the negative 5 m per s. I don't think my cheap little computer calculator is going to be happy about this one. K times 0.63. Sorry, I'm really bad about swapping numbers around. 0.826 m to the y. All right, so all I've done is I've put in the pieces. The concentration of NO2 raised to the x, the concentration of CO raised to the y, and the instantaneous rate put as the rate. And then, of course, the K is just in there as a letter because we don't know what it is. I'm going to do the same thing with the next 2. I'm just going to quickly write them. You can kind of see where I'm going with this. All right, and then the last one. All right, now we're ready to get started. Okay, so we want something to cancel. So let's find 2 things in brackets that are the same. Right here, our equations 1 and 2 both have the same number in the bracket. So let's start by putting 1 over 2. These 2 numbers are actually the same, so it doesn't matter which one we put on top because neither one on top is going to give us a fraction. So 1.44 times 10 to the negative 5. Ooh, why am I using green? I like to match colors so it's easier to follow what I'm doing. 1.44 times 10 to the negative 5 m per s will be on that side, and that's going to be equal to K, 0.263 m to the x, 0.826 m to the y. And then now let's take equation 2 and do the same thing. Okay. And as you're writing these in your notebook, if you feel very confident, you're welcome to kind of do some of the steps in your head, but be careful. All right, so the units cancel, and you can see that this divided by this is going to just be 1, but we have to worry about significant digits, so we're going to put 1.00. On this side, the k's cancel, this cancels, and we're left with 0.826. I'm not going to write the m because those are going to cancel. 0.413, and this raised to the y. I could stop right here, but I think probably some of you may need to see the next thing. You can see that 413 would double to 826, so I'm going to go ahead and just write 2.00. If that's not obvious, pull out your calculator. That's totally fine. So 2 to the something equals 1. What can I raise a number 2 to equal 1? Hopefully you remember this from algebra, that if you raise something to the 0, then the answer is going to be 1. So 2 to the 0 equals 1. So that means that y equals 0. All right, let's do the next one. So now we want to have 2 things that cancel. Let me see. I'm trying to decide if I want to. Yeah, I'll wait till later to explain more about that. All right, so now we need the y's to cancel. So we need two things in this column that are the same, and that's 2 and 3. Those two trials have the same thing. Which one is bigger on the rate side? We're going to put that one on top. That would be number 3. So, because they're both 10 to the negative 5th. So we just have to check the 5.76 compared to the 1.44. All right, so there's 1. K 0.526 to the x. And then we're doing number 2 with that, so 1.44. I just realized I accidentally forgot to put my unit in the top one. Let me fix that. Okay. I'm canceling things that cancel. The k's cancel, the units cancel, these things cancel, which is exactly why we did it. So on this side, I'm going to end up with 0.526 m over 0.263 m raised to the x. The m's will cancel. And on the other side, definitely not doing that one in my head. So 5.76. I think I'm just gonna, yeah. All right. The reason I just did that is because, just like in regular fractions, it's like these numbers are being multiplied by the 10 to the negative 5, and so that would cancel. And it just made it way easier to type in my calculator since they had the same like scientific notation format. I could just cancel those pieces. If one had been like 10 to the negative 5 and the other had been like 10 to the negative 4, I could not have done that. All right, so I got 4. I'm going to write it correctly with 4.00 because that's how many significant figures I have to worry about. On the other side, I have 0.526 divided by 0.263, which gives me 2. And so I have 4.00 equals 2.00 to the x. 2 to the what is 4? 2 to the second power is 4. So x equals 2. So we have, I'm going to go ahead and circle the pieces that we have. These aren't the answers. These are just pieces to get the answer. I probably should have listed up here at the beginning. We need to find x and y and k. So we've now found x and y. So now we're going to move on and we're going to find k. I'm going to slide this to the side so that you can see more going on. All right, so remember with the last one, we can use the same rate equation that's up here in the top box. We can plug in everything we know, which is literally everything except for the k now. We have 3 different options to choose. It doesn't matter which one you choose. I don't know if the book, which one did they choose? They used trial 1 again. So it doesn't matter. You could use trial 2 or 3 and you'll get the same answer. In fact, maybe I'll do trial 2 this time. All right, so the rate is 0.263. I'm doing trial 2. It doesn't matter, but just so you know. Oh, you know what? It would be helpful if I looked at the right number, though. We're starting with the rate. So right here is where I'm starting. So 1.44 times 10 to the negative 5. That's our rate. It equals our rate constant that we're trying to find. And then we have first is 2.263. 0.263 m, and that's our x. So let me squiz this up while I write this. All right, and then times the molarity of the other one, which is doing number 2, so 0.413 m, and that one is raised to the 0 power because that's what our y was. All right, so you see where I got all the numbers from? The numbers that I put in for the bracket M, the molarity area, and the instantaneous rate came from this row. My y came from here, my x came from here, and then my k is the thing that I don't know. Now, we just discussed this. Anything raised to the 0 power is 1. So this whole thing right here is just going to be like times 1. So because of that, I can just basically ignore it and just drop it out of the equation. So then I'm just left with 1.44 times 10 to the negative 5 m per s, which I forgot to write, equals k. And we're going to divide both sides by 0.263 m, and that's squared, to get k. Okay. All right, so 1.44 times 10 to the negative 5. It might have been easier just to turn into a decimal. Divided by, and I'm going to put this in parentheses so I can square it on my little cheap calculator here. All right. Well, that's a mess. Okay, so that little e minus 4 means times 10 to the negative 4, which we've done before. And so we can write it like that, or we can write it, in the book they wrote it just laid out. So we need to keep 1, 2, 3 significant digits. So 2.08 times 10 to the negative 4 is what my calculator gave me. And the answer in the book, the way they have it written, is because this is negative, you can just move the decimal 4 places this way and put it there. So 0.123. Either of those answers is fine. You can write it in scientific notation, or you can write it in not scientific notation. Either way, you need to put your units. So we have 2 m's on the bottom. M squared is kind of like m times m, so one of those cancels. I don't really want to write it there. So we have m over s, and we have m squared on the bottom. So we get rid of the square, we get rid of the m, and we're left with just an s on the bottom here, and the m that's already on the bottom. So m times s. So there's our rate constant. So now we have our third piece of information. So now we can build our equation. So I'm going to point out one thing, and then I'm going to simplify the equation. I'm going to write it big all down here at the bottom. Okay? All right, so my rate equation is rate. Remember, the rate changes based on the concentration, so that's just the word rate. K is important. That's a constant, so 0.00020. Oops, why did I write an 8 when I said 0? 8, 1 over times s. And then that is going to be, our first one is N O, this is really hard to read now that I've zoomed out and I'm writing this big, to the X, which is 2. And then the second one is CO, and that one is 0. You could leave it this way, but remember, something raised to the 0 is just going to be 1. So that means we actually don't need this piece at all. We can just leave this off. That means this reaction only depends on the concentration of the NO2. It does not depend on the CO. So, and you can kind of see that over here. We changed the amount of this concentration here. I mean, not concentration. We kept, let me do it on the right one. We changed the concentration here, but the rate didn't change. This one stayed the same. This one changed. So if the CO had any effect, this number right here would have changed when we changed the CO, but it didn't. It only changed when we changed this one. When we changed this one, then the rate changed. So the CO has no effect on the rate of the reaction. Obviously, it has an effect in the reaction itself, but it doesn't have an effect on the rate. It doesn't matter how concentrated that CO is. You could have it extra packed in there, and it whatever, wouldn't matter. All right. I hope that makes sense. Again, the path was that we wrote the rate equation. We recognized what pieces have to be filled out, which is the K, the X, and the Y, which means we needed to find all of them. And we started by finding the X and the Y first because we can do that using some fancy math, which is the blue, green, purple, messy section. And then once we have our X and Y, we can use any of the trials to find the K. And then once we have the K, then we're able to write our rate equation.